welcome back. Now, currently, we would have learned about electric currents and so forth, electric charges and so on. Right? Now, we're going to move on to understanding about the term voltage, right? Otherwise referred to as potential difference. Voltage, otherwise known as potential difference. Correct. Right. Now, Now, voltage basically describes the amount of energy needed to move the charges along the conducting path, right? So we would have learned about electric current, which is the movement or the rate at which the electric charges flow through these conductors. Now, voltage basically is a description of the amount of energy needed to move these charges along that conducting path, right? So in that event, you will get a different set of definitions. Like for instance, the definition of potential difference or PD, right? We said that the potential difference between 2 points in a circuit is the energy used in transferring unit charge between these points. I'll repeat that so you could just hear it. Is the potential difference between 2 points, right? Is the energy used in transferring unit charge between these 2 points. So it means the amount of energy needed to move the charge from this location to this location. How much energy is needed to move the charge along that path? Good. Also, we have that term electromotive force, EMF. All right. So we use the symbol V, or in some cases we use PD in this case. PD. Now, there's another term known as the electromotive force. Electromotive force, otherwise known as EMF. Right? Textbook definition says that it is the electromotive force of a cell is the energy used in transferring unit charge around a complete circuit, including through the cell itself. Now, in the case of voltage or potential difference is the amount of energy needed to move a charge across a component from this point to this point. Whereas electromotive force is the amount of energy from a cell. When we say cell, it means from the battery or from the power source. The amount of energy needed to transfer these charges around the entire circuit. So if we talk about around a simple circuit or around a parallel circuit, we want to see how much energy in all do you need to transfer these charges around the complete circuit. So you're going to see that electromotive force or EMF is the energy, is the total voltage supplied by the battery source. Good. Whereas the voltage or the potential difference is the voltage across a component. Okay. Now, so given that bit of explanation, we're going to realize that voltage follows a simple formula where voltage is equal to the amount of energy per unit charge. Energy per unit charge. So it gives us that V is equal to E over Q. Good? V is equal to E over Q. Where you're going to realize that the SI unit of voltage is volts. Alright, so joules is measured, energy is measured in joules, and charge is measured in coulombs. Joules for coulombs is equal to volts, right? Or GC, just -1 is equal to volts. So that's the SI unit of voltage, right? Voltage is measured in volts. Now, this formula relates to voltage. This formula also relates to electromotive force. Good? whereby EMF is also referred to as the voltage total voltage delivered by the battery. Good. So in this case, it will be total volts is equal to the total energy divided by the charge. Total charge. So V total is equal to the total energy needed to transfer this charge around divided by the total energy divided by the total charge. Right? So we see the two formulas here which are similar, but one refers to the total amount of energy needed to transfer the charge around the complete circuit, whereas this one just looks at the amount of energy needed to transfer it across a component. Okay? Now, as we go through, we're going to also see that it varies with circuits, right? With different types of circuits. So I'm going to introduce the two different types of circuit to you that we look at in the syllabus. Now there are two types of circuit. One is known as a series circuit, and the other one is known as a parallel circuit. Afternoon. Alright, so as I was saying, there are two different types of circuits. We have series circuits and parallel circuits. So I have a diagram here to illustrate a simple series circuit and a parallel circuit. Now the difference between the two, a simple well, a series circuit is where the components are all connected in one continuous flow in terms of series connection, one after the other, right? So basically you're gonna have the battery is then connected to the bulb, which is connected to another component. In this case it's an ammeter, then a switch, and then back around. You have one continuous loop, right? There is only one part in which the current can flow in. So that's why we refer to it as series. One continuous line, so it's a series connection, right? The next one is a parallel circuit. In the case of a parallel circuit, you're going to find out that there is more than one part in which current can flow, right? In terms of unbroken paths. So in the case of conventional current flow, we can realize that the current can flow from the positive side of the battery around this loop and back. The current can flow here at this junction. It can go down to this other junction and come back around and join up there. And then thirdly, it can travel through this third loop, up, around, and so. So it has 1, 2, 3 possible routes in which it can take. So that is referred to as a parallel circuit, right? Three different avenues in which current can flow. Now, we want to understand the importance of learning the difference between these two circuits. Right? Now, as it relates to the current and it relates to the voltage, that is what we're going to focus on. These are two things that we would have just previously learned. Right? So we learned that the current is the rate of flow of electric charge around that conducting part. And we learned that voltage is the energy per unit charge, the amount of energy needed to transfer these charges around that circuit. Now, some things you're going to learn about these circuits. Firstly, in the case of a series circuit, the current is kept constant. Right? That is one of the first things we're going to learn about a series circuit. The current is constant in a series circuit. So it means that if 3 amps of current is delivered by the battery, then it means that 3 amps of current is going to travel through this bulb. It means 3 amps of current is going to be registered on this ammeter. It means 3 amps of current is going to pass through the switch, and 3 amps of current is going to go back to the batteries. That is what it means by the current is constant. In a series circuit, the current always stays constant. Good? Next one is that the voltage varies. The voltage varies across each component. Now, we learned the difference between EMF and voltage or potential difference, right? Where EMF is the total voltage delivered at the battery source, right? So it's the total voltage delivered at the battery source. And what we will find out about the voltage now, or the potential difference, is the amount of energy needed to move the charge from this point of the component to this point of the component. From this point to that point. Good? That is what the voltage is. So in this case, what we're saying that the voltage varies. For instance, if this power source here delivers 6 volts, 6 volts of current, it means that the 6 volts is divided up among each of the components in that simple circuit. The total of 6 volts is divided up among everything else. Okay, so it means that this bulb could take let's say 4 volts of current. This ammeter can take 1 volt of current, and let's just say the switch take another voltage, right? So it means that 4 plus 1 plus 1 adds up to 6 volts. 6 volts goes back to it. So all 6 is divided up to these components. Right? Let's just see the switch doesn't have any. So it has 2 here and 4 there. Good? Now, the only thing about a voltage, to measure voltage across any component, is that you have to use a voltmeter. A voltmeter is a device used to measure the voltage, whereas ammeter measures current. Now, to measure the voltage across it, how would we know? Like, for instance, you said 4 volts there. How do we know 4 volts is needed to carry charge from this point to that point? Is that we have to hook up a voltmeter. And a voltmeter is always connected in parallel to a component. As you just mentioned there, the parallel is providing another route in which charge can take. So in this case, you have to hook up a voltmeter in parallel to the bulb. So in terms of when charge comes here, charge can go around this avenue and then come down, rather than coming straight across. Rather than coming straight across, it can go around this loop and then come down. So it means that the voltmeter is connected in parallel to this bulb. Okay? We can do it here as well. That the voltmeter is connected in parallel to this bulb, as we can see there. Good? So we say that the current is constant, however, the voltage varies across a component. So it means that the total voltage, which is the EMF, is equal to the voltage delivered here, that's V1, and the voltage delivered here, that's V2. So, what we're saying here, voltage varies. So, total voltage Vt is equal to V1 plus V2. Right? V1 plus V2. That is what we're going to find out about total voltage there. Good? Now, that's the main thing. So the current is constant, so the current is always the same value at each component. Voltage, it varies across the circuit. Good? Secondly, parallel circuit. Let's see how it differs. Now, one thing I must let you know is that out of these 2 circuits, your homes are connected in parallel circuits, right? Now, one of the things that you know about a parallel circuit, at your home, is that if you go to any socket to plug in your device, that all of these sockets may give you 220 volts. That's the amount of voltage our electrical company gives us here, 220 volts, right? So you can go to any socket in your house and get that. Right? If you have special houses that has a giant transformer that you have 110 connection, that those special connections, no matter where you go, you always get 110 volts. Now it means now that voltage is constant anywhere throughout your home. Alright? So that is one of the things you're going to see about a parallel connection, that the voltage is constant. The voltage is constant. So it means that the total voltage delivered at the battery source, the EMF, the 6 volts here. The total voltage there is going to be the same amount of voltage across each of the components in this circuit. So if we measure the voltage at this point, it's 6 volts. We measure the voltage passing through this bulb is also 6 volts. Voltage passing through this bulb is also 6 volts because they're all connected in parallel, right? So the voltage is constant. So 6 volts, 6 volts, 6 volts. Same 6 volts at the power source, the EMF. Good? So basically we're saying that the total voltage is equal to the voltage 1, which is equal to the voltage 2, which is equal to the voltage 3. This is V1, V2, V3. Good? That's what we mean there, that they are equal. Next point, in this case, if the voltage is constant now, it means something about the current. The current varies across each component. Good? The current varies across each component. Now in this case, what you get to understand is that due to what is known as Kirchhoff's law, whereby the current entering a junction is equal to the total current leaving that junction, right? So it means now the total current coming from the battery source that is going to enter the junction is going to split up, and when it leaves the junction going back around, they're going to add back up to the same total amount of current. So if this power source is, let's say it delivered 13 amps of current, that the 13 amps are therefore going to come and they're going to travel through the different junctions. Some are going to go up this way, some is going to go straight and travel up here, and then the others go straight and travel up there. So the 13 amps are going to be separated, they're going to be divided up. So let's say 5 amps go here, 5 amps go there, and then 3 amps go here. 5 and 5 is 10 and 3 is 13, right? So when the 5 goes across there, 5 amps passes this bulb, 5 amps pass that bulb, 3 amps pass that bulb, and when they come back, they all add back up. The 5 and the 3 add back to 8, and then the 5 and the 8 and the 5 add back to 13 amps. So that is what you will understand when you read up on Kirchhoff's law. The total voltage entering a junction is going to be equal to the total voltage leaving the junction going back to the power source. So hence the current varies. So the I total is going to be equal to the I1 plus the I2 plus the I3. Good? So that is what we refer to as Kirchhoff's law. Okay? So these are the main things that we need to learn about the different types of circuits in terms of series circuit and parallel circuit. So all I would have done now is just introduce to you about the current and the voltage. Now, one of the next things that we need to learn is about resistance, right? We're gonna cover that in the next segment.